Hi all, my name is Alejandro. Over the past few months, I've done some experiments using Rust to directly send hypercalls to Xen and seeing how we could potentially offload this effort to improve our tool stack and everything else. I hope that towards the end of the presentation, I will have convinced at least some of you that starting doing things in Rust, at least in the tool stack, is a worthy effort to pursue. That's roughly the outline I want to go through. For those of you that don't have a deep understanding of Rust, I'm not going to go very much into it, but better than I can explain it, the book Rust by Example explains it fairly well. It's a modern systems programming language focusing on safety, speed, and concurrency, and accomplishes this goal by being memory safe, which is good. It also sounds a bit empty without further context. Basically, Rust makes a bunch of promises about lifetimes, about borrowing, about ownership, and tries to statically prevent you from shooting your own foot, which is generally a good thing to guarantee. As far as I'm personally concerned, I care less about the headlines they usually get into the ads for Rust and everything else. What I care about it is that it's very close to the metal in that sense. It can very much mimic what C does, or even C++. I also care that it has first-class support for higher-level constructs, so we can talk about dynamic memory management if we so desire. We can talk about vectors, we can talk about hash tables, we can talk about a lot of things that are very helpful when you want to create a robust tool stack. Nowadays, and I'm going to piggyback a bit on the current issues with XZ and supply chain poisoning effects, Rust provides a reasonably closed ecosystem, which allows it to very, very simply gives you the full view of all your transitive dependencies. From this point of view, it's reasonably easy to look at it all, audit your dependencies, and make sure that you have not introduced an existing vulnerability that everyone knows about, but you haven't because, you didn't know that, you pulled that one dependency. So that is nice. And on top of that, the type safety that it brings is just far superior, even when compared to other big languages that are strongly typed. So when I started playing around with this, goofing around, these were roughly the questions that I wanted asked. If I want to create native bindings for Rust, how hard would it be? Would it be very annoying? Would it be something that can scale and be brought side by side with the C existing ones? Furthermore, can I actually use them both for freestanding cases, meaning kernels, unikernels, and the user space counterparts? Can I create a unified interface that it works on both? And can I please not link against the existing libraries? That would be good. I'm going to give you the spoilers first. And yes, we can make a library that works on both kernels and user space with a bit of care. No, we don't have to link against the existing libraries. In fact, it's far easier if you don't. And about how hard it is to write the bindings, well, it's not hard. But it is hard if you want to maintain them over time. Fortunately, there are solutions for that, and I'll get to them in a bit. Currently, this is the state of affairs, at least as far as Excel goes. Excel when you do something to Excel, say execute XLD message to pull the kernel console, the hypervisor console. That will go through a dynamic library, libxl. That will do some allocations, and it will do a few more things. That will connect then with a collection of static libraries that have some, well, interdependencies between them. And that will eventually land onto some I/O cattle device on the kernel that you're running, be it Linux, FreeBSD, or whatever. Then the kernel performs a forward of the hypercall into the actual hypervisor, and everyone is happy after. The problem here is that there's a big collection of static libraries, and because they are all written in C, it is complicated to make a risk assessment of what is the entailed complexity between making a call in Excel and getting outputs at the other end. So that's what we have. And ideally, I'd like to substitute the dynamic library and the static libraries by a single Rust library that does it all. There are further problems. I cannot just use these libraries on bare metal. I cannot make kernels with it. And when I made these slides, I made that statement, and that seemed right. In practice, it might be possible to link them against something like MiniOS, but regardless, it's not a trivial thing to do, even if it's possible. Plus, it's all C, so no vectors, no strong type checking. God knows, no borrow checker. So, yes, can we do better? I built a small proof of concept of this, and it essentially creates a library and a collection and a couple of binaries to exercise the idea. I want this thing to be usable by hosted and freestanding environments, and I don't want to rely on XC, XL, XG, Evention, so on and so forth. And does Rust bring anything? Well, yes, it is easier. That's the way I ended up architecting it. Architecting might be a strong word. It's a proof of concept. It's not ready-made for ready use. It is a common library. Rather than splitting how the kernels and the user space applications talk to the hypervisor, there is a common interface that both can use, so you can pretty much exercise the same sort of hypercalls from both ends, and it will do the right thing. And after listening to the Unicraft talk, I'm guessing that's something that might be helpful. The library itself is divided into segregated in two parts. In Rust lingo, something is STD if it's hosted and it has a standard library on top. Something is no STD if it has no reliance on such things. So in practice, it's not that hard to go and create a primitive thing on no STD and then have the STD part use that when needed. So we can have high-level abstractions when we can have them and not have them where we don't. The no STD part can issue raw hypercalls using the hypercall page, and the standard part can use the IO cattle directly and bypass a whole lot of complexity. So initially I thought, okay, can I make something that on a command line that kind of resembles Excel? So yeah, fine. I'm going to create a stateless CRI like Excel, and following the spirit of creating command line interfaces that start with X and is followed by another random letter, I just decided to allocate one. That's mine. I stopped at a single hypercall being read console, and it became pretty obvious in a bit why. So whenever I execute XR the message, I get those usage statements. And as it turns out, writing CLIs in Rust is very, very, very easy and very, very convenient. In particular, I didn't have to write any parser at all. Those things are comments on the structs that define the demarshal forms of the usage messages. So not having appropriate documentation in your usage becomes even more unacceptable because it's just easy. So yeah, with that I can get the right commands and everything else. So that's good, +1 for Rust. I won't dwell too much into this, but for every hypercall that we want to migrate into a binding, we must create a struct, like the one on the right, sorry. We must create a struct that mimics the C counterpart that lives within the hypervisor. They must be binary compatible. There must not be any padding differences between them. If there is padding differences between them, bad things will happen, and you will struggle to find it. So that was done by hand with the comments that already exist, but that was done by hand. The important bit here is the existence, and I won't dwell too much into it, but of that send interface command parameter. That is very similar to the existing libraries concept of XenCall, which effectively acts as OSDEP. That means that you can basically exchange one thing for another, and that will work for Linux, that will work for BSD, that will work for... We have code for Solaris, I'm not sure that works. But it's a matter of adding yet another variant of that is no STD, that performs raw hypercalls. So that's good, that covers the uniformity requirement that I auto-impose myself. However, shortly after writing that one hypercall, I realized, oof, I really don't want to do this for all of them, because there's a lot of them. And the worst part is that by the time that I'm done with them, I will have to start over because those interfaces are unstable. So they can change over time. And even if I manage to get to a point in which, yes, I'm done, and yes, they are in sync, I'm pretty sure that they will not be in sync for long. And at some point, someone is going to update the C version, and who uses Rust anyway? So can we somehow solve both of these problems? Can we write a single specification of our hypercalls and get bindings for free? And, well, yes. I wrote a little ideal parser. Again, it's a little experiment that generates only that specific hypercall. It uses TOML, but there's no particular reason to use that one. If you prefer JSON as your poison, now nothing prevents us from doing that. It happens to be written in Rust because it's convenient to write parsers in that. And it auto-generates C and Rust files. In particular, it looks kind of like that. I'm hoping it can be read, but if not, it's a very generic looking TOML file. The specification is on the left, and for each struct, it very precisely identifies the name. What's its name? What's its description? What are its fields? What are their types and lengths? And peanut butter sandwiches. After you define all of this, you run it through a tool, the tool that I just showed in the GitLab repo. And it will generate something like that's on the right. The thing on the right is not the source material. The thing on the right is the generated C header file given the specification on the right. In particular, and I do wonder, does this work? Yes. In particular, that's a pointer to a uint8, and that gets converted into our own macro for type safety in C, because that's how C works and operates. That's how our ABI in Xen works. So I can generate C, that's good. I can also generate Rust. And it works fine. As long as you're doing primitive types, these approach scales very nicely. There are still some, oh yeah, and there's also the very nice touch of the underscores in the name get converted to camel case. Because, of course, we want our formatting conventions to be right? So with this, I can generate structs that are basically using primitive types and pointer types and that sort of thing. Some hypercalls don't quite fit nicely into this model, and that is a thorny issue that I'm still working around, but it shouldn't take very, very long until that is sorted. My intention with this is to specify some more interesting hypercalls, namely hypercalls that are themselves containing unions, other substructs. If things are very complicated to specify, they're probably too complicated to exist too. So my intention is to eventually develop a plan of action so that we can have this sort of ideal generating the structs that Xen itself uses. This does not mean that Rust gets to live in Xen or be used within Xen, at least not yet. But it will at least enable the usage of the hypercall structs and define and do direct raw hypercalls from not only C and Rust. If the day after tomorrow we want to do it in Go, nothing prevents us from doing that. We have at least 2 tool stacks that use OCaml and Haskell that might or might not be interested in having native bindings as well. So yes, my intention is to have this all upstreamed and incrementally switch the existing hand-coded things into something more carefully specified. And that's about it all. Any questions?
So with you basically rewriting those low-level libraries in Rust, would it be possible, so merging them all into one big Rust library, right?
Well, not quite. The point is not to rewrite the existing libraries.
No, the point is to have basically a safe approach, a Rust-based approach until the hypercode or the ISDTL, right? That you can track all the memory usage and so on.
So I'm not sure I follow.
So you did for the XR stuff?
Yes.
Everything you
Yes.
would it be possible to replace the current C-written libraries with Rust ones so you can prove for your XR command or then probably still XL command to use Rust-based libraries?
Yes. That's something that I haven't fleshed out yet. One intermediate step that I would like to get to is to split the Rust library into 2 and have one part that exposes true native data types from Rust to Rust, because that is convenient and type safe and allows you to create safe interfaces. And then shortly after that layer, have another layer that is an FFI to use C-based conventions, so that we can actually offload the benefits of static checking with Rust, but for C. Note, though, that this does not necessarily mean that you'll end up in a memory-safe situation. By necessity, if you pass a buffer.
On the Rust side, yes, but not on the C side, of course. But
Yeah.
you would obviously have only one implementation of the libraries then and wouldn't have to change both sides as an interface is changing. Or if you add a new feature, for example.
There are several ways to go about that particular thorn. One possible way to go about it is, let's be careful and not make unstable interfaces.
Adding a new feature, for example.
Yes.
So you would only have to add it on the Rust side, basically, and maybe modify or expand the current interface, even on the C side. Never mind. But you wouldn't have to do it in Rust and in C.
Well, yes. I mean, definitely, if I could simply have one library written in Rust that is canonical and is our canonical FFI into the hypercalls, that would be fantastic.
Yeah. So I think this is a good way to approach it, because then you don't have two things
Yeah.
in parallel, but could slowly basically drop the C side. At least in our repository, what other users do, well, let's do it, and let them do it. But they would use the Rust library.
Yes. Yeah, that sounds perfect. Oh, sorry.
Could you generate, in addition to automatically generating the structs, could you automatically generate the safe wrappers?
Safety is a relative term. We could and probably should generate a bit more than the C structures, because there's things like that must exist as such, like the opcode number for the hypercalls and things like that. But at the end of the day, if this thing is exposed in a sort of FFI for someone else, it cannot really use the advantages that Rust brings in terms of initialization. We can try to make it as safe as we can.
I meant for pure for users that are.
Oh no, absolutely. The whole plan will be to have an interface that no, you don't get to give it a raw pointer into memory. You give it a slice, and if you have safe Rust before that, your slice is perfectly good. And yes, the interfaces that I wrote don't try to meddle with pointers and memory. It uses, to the extent that is possible, safe Rust. But by the time you hit the IO cattle, you do have to use unsafe because it's not under your control. Depends on the safety of the module. But yes.
Could you make it so that there's no handwritten unsafe and all the unsafe is generated, at least for the non-SSI parts?
It's self-contained. It's only written once for doing the actual IO cattles or the raw hypercalls. But everything else should be safe Rust. Should.
One other question regarding the generation of the hypercall
Mm-hmm.
characters. Are you planning to create this the compact structures as well for 32-bit text?
Daddy.
So this would be, I think, interesting. Jan might be opinion I'm not sure, but having just one tool acting on the same input file might be better than generating the C structures and then out of those generating complex structures.
So by the compact structures, I get you mean the compatibility structures that were created for the 32-bit variants. Yes. Ideally, I'd like to auto-generate absolutely everything because I do want to be able to use these tools even on 32-bit targets.
It's probably worth saying that a different project we have going on right now is post-UEFI secure, for which we are having to delete all of those libraries anyway. One of the things that Microsoft has enforced on us is we cannot use that IOTA because it violates the boundary that Microsoft wants with secure boot in that user space can't issue unchecked accesses. So as part of that, we are rewriting the entire user space tool stack interface. A side effect of that is it's going to become unstable. It's going to lose its differences between 32 and 64-bit to the extent that that was anything the tool stack uses. The existing hypercalls that have those differences, they'll stay for now, but frankly.
Well, I mean, they need to exist. At the very least, you have the HVM ops and.
Yeah, the stuff that the guest kernels currently use can't change. We can provide some more sane options because even some of the guest APIs we have at the moment are mad.
That's one way of putting it. Okay, anyone else?
Okay, so have you thought about other? I don't know too much about like. We already have like the LibXL.
The IDL.
So I mean, are there better options for IDLs? Just kind of rolling our own again, or?
Well, this is not quite rolling my own. I'm rolling my own in the sense that I'm specifying the fields by hand. But the serialization and deserialization mechanisms are generic. I'm particularly using Rust's SERDE. So I don't get to look at the intermediates of tokenizing and everything else. I really just provide this is a vector of foos, this is a vector of bars, this is a vector of buses, and just collect them at the end and make sure that I'm writing the right things at the end. The complexity comes from writing the right target language rather than parsing the IDL.
Sure, but I mean, like, we're not the first project ever to have written an IDL, right? So are there other projects that have already figured out how to do specification such that it generates useful Rust and C and Golang? Because you can say the same thing about the LibXL IDL is written in Python, because basically we just take it and run it, and there you go, you have Python. So express in our IDL because of decisions we made because we didn't know how to write an IDL. Does that make sense?
Yes, it does. Bear in mind there's another interpretation of that. So if your specification is so complicated that you cannot readily express it in a markup language that is by nature simple, can you redefine your specification in a way that you can fit it in? Because that will turn out to be a much simpler form of it.
Sometimes we did that, we had to do compatibility tags to keep it working, so that's part of the reason of some of the complexity that we have in the IDL, because we had to keep the old structures compatible with the new ones.
That's a good point, because in Rust the answer is there's no ABI. That's Rust's answer is throw out ABI.
Well, you can do rep-c, which is what these things do to allow it to interface with Xen. Yeah, I don't have a good answer for that. I'm not aware, I haven't looked deeply into the sort of complexities that the existing libxl IDL has found.
The question is to express the binary representation of a structure, right? In memory.
Yes.
There is a project called Struct, which is intended for parsers mainly, but aims to generate code for memory representation, but it only works for some files.
Okay.
Which can do C++, C#, Go, Java, JavaScript, Golang, whatsoever.
Okay, that sounds promising. I'll go fetch you later.
On the libxl compatibility side, that's mostly in the case of retrofitting security fixes, and a lot of them are a consequence of libxl's own making.
Well,
Because we cannot change the API. The problem is that for non-security fixes, we cannot change the API, so we cannot change the C representation of the structure. We can change the binary value, but not the C representation of the structure.
well, I think we're running over time here, so we can follow it up later. Well, thank you.